Hello everyone, my name is Abhishek and welcome back to my channel. During the last week, a major security attack took place. The attack was executed by AI and the attack was performed through the CI/CD pipelines on the repositories, typically GitHub actions on the repositories. And the attack was so severe, even the top repositories on GitHub were no exception for this attack. What actually happened? Someone created a project called Hackerbot-Claw. This is an AI project, and the goal of this project is to look at hundreds of thousands of repositories on GitHub and identify vulnerable CI/CD pipelines. Once it identifies the vulnerable CI/CD pipelines, through the pipelines, it got access to the repositories and it went ahead and deleted the source code from the repositories. Even on some project, it deleted releases from the repositories. So obviously, a lot of people who are using these repositories were also impacted. In today's video, I'll tell you what actually happened, and I'll also tell you how did these hackers or AI actually perform this attack. This is a very interesting video, especially if you are a DevOps or cloud engineer, because the attack was executed through the GitHub actions. And everyone, especially DevOps engineers, should go back and fix the GitHub actions in their organizations. So make sure you watch this video till the end. Let's first look at the security incident that is posted by Trivy, which is an affected repository. And I'm sure you all know what is Trivy. It is very, very popular in the space of DevOps. We will understand the severity of the attack through this incident, and then we will head to the whiteboard to understand how did they actually perform the attack. So the incident says Trivy has been attacked today via GitHub Actions. This was posted 3 days ago, along with other popular projects. So you can see the projects here. So this is one repository from Microsoft, Datadog, Awesome Go, Acri project, Aqua Security Trivy, even Rust Python was also impacted. Of course, there are hundreds of other projects, but these are very, very popular ones. And what exactly did they do? The repository was made private so that nobody can access the repository. So they changed the name of the Trivy repository to private Trivy. And then the public repository, they emptied the code. So if someone looks at the public repository, the actual Trivy repository, they will not find any code in the main branch. Imagine such a popular repository's code completely being eliminated. And they did not stop the attack there. They went ahead and they deleted the GitHub releases. What are GitHub releases? Basically the artifacts. Let's say the latest release of Trivy is 0.69.1. All the artifacts to run Trivy on Windows, to run Trivy on Linux, Mac, they were deleted. And they were deleted from 0.27 release to 0.69 release. That is, almost 42 releases were deleted. So even if you want to go back to the last 2 releases, 3 releases, even if you go until last 42 releases, you will not find any artifacts. And obviously, hundreds of users are impacted. And also a malicious artifact was posted to the Visual Studio Code extension. So if someone is using the Trivy extension in Visual Studio Code, they are also impacted. So Trivy, I appreciate them. They posted a very detailed security incident so that we at least understand the severity of the attack. Now the big question is, how did this happen? I mean, how did they perform attack? Through the CI/CD pipelines. So there are different techniques this Hackerbot-Claw used, but 2 techniques that stands out and 2 techniques that I want to discuss in the video. One is called branch name injection attack. This is a very, very interesting attack. I was quite surprised when I was reading about it. Like, how did they even come up with this attack? And the other one, which is complementing this attack, is called pull request target abuse. Let's first understand this one. Now, if you have used GitHub Actions in the past, by default GitHub Actions supports a lot of environment variables. For example, if you want to get the name of the branch, or if you want to get the commit ID, which triggered the pull request. There are some default environment variables. For the name of the branch, you can just use this variable github.head_ref. Even if you look at one of our CI/CD pipelines, we use such environment variables. So this is for my Go application, where in the CI/CD pipeline, I used a variable for the Docker image tag, github.runID. This will get the GitHub action run ID. In the same way, if someone use github.head_ref within the CI/CD pipeline, they can get the name of the branch. Now, they can use it anywhere. Even in the CI/CD pipeline, they might write a simple echo statement. The CI/CD pipeline is running for the pull request against XYZ branch. Or just like how I used the commit ID here, the run ID here, instead of this, they can go with github.head_ref as the Docker image tag. Now, if someone is using this environment variable within the CI/CD pipelines, they were attacked. How? So what this Hackerbot-Claw did, it created the name of the branches. It used a very strange branch names. It used something like feature. Usually the name of the branches would be feature or name of your bug fix, but feature colon curl a particular script that it could download /bash. Now this entire thing is the name of the branch that it used. Because in GitHub, there is no particular restriction what should be the name of the branch. So it chose this as the name of the branch. And now when this is passed to the environment variable, let's say XYZ repository or Trivy repository is using this environment variable, and they use $this environment variable. So this will, if this branch name is provided, this will be executed as a shell command. So this will be executed first and this will be executed next. And when the script is executed, where does the script get executed? It will be executed on the GitHub runner. And GitHub runner by default has all the secrets that you stored within the repository. It has access to the secrets. And it also has access to things like personal access token. Not your personal access token, but when GitHub actions run, it gets a personal access token so that it can perform actions on your behalf. Similarly, let's say you used AWS secrets or you used your Terraform secret, whatever it is, they were compromised. I'll repeat this. I know this is slightly tricky. If you're a beginner, you will find it little difficult to understand. So I'll repeat it one more time. Basically, when you run GitHub actions, by default, GitHub action supports a lot of environment variables. Some variables like github.headReference, github.runID, github.commitID, so that you don't have to fetch the variables or you don't have to fetch certain values. GitHub provides them out of the box for you. And if someone is using this particular variable, they will get the name of the branch against which the pull request is being executed. And the Hackerbot-Claw, which I explained you, it targeted this environment variable. How did it target? It created pull request to the repository, right? If you're talking about Trivy repository, it created pull request to the Trivy repository, and the pull request was created from a branch name like this: feature colon curl a script that it could download, followed by -bash. This is all the name of the branch. And when this environment variable tried to resolve within the CI/CD pipeline, this time this script got executed because of the bad intention of the AI. It downloaded a script and it executed the script. Now where the script is running? The script is running on the GitHub runner. And GitHub runner has access to the sensitive information like personal access token, AWS secrets, whatnot. Whatever you store in the GitHub repository secrets. This way, the AI started compromising, or it started attacking popular repositories. Trivy was attacked, Microsoft was attacked, Datadog was attacked, and many other popular repositories. Now you might say, but Abhishek, you know, did GitHub not think about it in the past? One is this is a very tricky attack. Second, to some extent, GitHub thought about it. What GitHub said, if someone is using within the CI/CD pipeline, if someone is using, here I'm using the push action, right? So this CI/CD pipeline is executed only on the push, that is only on the commit. Similarly, I can use pull request, and I can also use something called pull underscore request underscore target. So the bottom line is that if someone is using just pull underscore request, they are not severely attacked, because when you use pull underscore request, the personal access token that GitHub runner gets access to, it does not have repository admin privileges. But if someone used pull underscore request underscore target in this particular section, the personal access token, which is used by the runner, it has escalated privileges. Unfortunately, repos like Trivy, they use this kind of action. And because of that, the personal access token, which is accessed by the runner, it got repository admin access. And eventually, you know what happened? They deleted the source code, they deleted the tags or the releases from the repository, and they even move the actual branch, actual repository to a private repository. Everything because they got access to the repository administration. So what you have to do now, very simple. If you are a DevOps engineer, check for two things. The first thing that you would check in the on action within your CI/CD pipelines, if you are using the push action, pull request action, or pull request underscore target action. This is mostly used, right? This is mostly used for commenting on the pull requests. Like usually some people create bot accounts, and through the bot accounts, they comment on the repository, they add labels to the pull request, they add comments on the pull request. In such cases, people go with pull underscore request underscore target, right? So check for this first. And if you find this, now you have to be cautious. Then search the entire repository, search all your CI/CD pipelines to see if you have used GitHub dot head underscore reference. If you are using this environment variable as well, then you are about to be compromised. There is a possibility you will be under attack, especially if you are using a public repository. So go ahead and change your CI/CD pipeline. Instead of this one, maybe you can use a different environment variable, or you can get the branch name through some other way. Now, this is a very new attack. To be very honest, not a lot of information is available on the internet. Even I had to go through multiple sources. Then I had to read the GitHub discussions from Trivy, other sources. I had to follow some Reddit conversations. Only then I understood what actually happened. In the coming days, we will definitely have the more information. And once we have the more information, I'll record another detailed video talking about all the attacks that are performed by Hackerbot-Claw. For now, just share it with every DevOps engineer that you know, because you cannot allow the Hackerbot-Claw or any other bot accounts to hack your CI/CD pipelines. Same thing can happen to your organization, just like what happened to Trivy. Fortunately, at this point, GitHub actually suspended that repository. If you search for Hackerbot-Claw, you will not find it, but they might create a new repository. They might come up with a different way of attack. So be cautious. Thank you so much for watching today's video. Let me know in the comment section if you have any question or if you did not understand any specific thing of the video. See you all in the next video. Take care.